Question number 7. How many different arrangements are there of the 9 letters in the word intellect in which the two T's are together? Now, first let us see that what different alphabets I have. So let us start with I. I is 1 in number. N. N is also 1 in number. T. T is 2 in number. E is also 2 in number. L is 2 in number and C is 1 in number. So 1, 2, 4, 6, 8 and 1, 9. Okay, so these are the 9 letters we have. Now, how many different arrangements of these 9 letters in the word intellect in which the two T's are together? Now, when two T's are together, we will consider those two T's as one alphabet, and therefore out of this 9, now I have 8 alphabet. They can arrange in 8 factorial ways, but out of these 8 factorial ways, we have 2 alphabets E and 2 alphabets L. So I will divide by 2 factorial for E and 2 factorial for your L. So your total number of arrangement will become 8 factorial divided by 2 factorial times 2 factorial is 4 only. So 10,080. 10,080 is the total number of arrangement. Now, the second question. So here you understand that when two T's are together, we can consider them as one alphabet. Now, as both are T only, so they themselves cannot arrange in 2 factorial ways. And if there is some repetition of words, alphabets, we know that we have to divide by, like if 3 alphabets are repeating, so by 3 factorial, if 2 are repeating by 2 factorial, and so on. Next question. How many different arrangements are there of the 9 letters in the word intellect in which there is a T at each end and 2 E's are not next to each other? Okay, so now here we can solve problem in 2 different ways. Now, as 2 T's are at each end, so their positions are fixed. That means out of 9, we have to now arrange only 7 alphabets. Now, 7 alphabets can be arranged in 7 factorial divided by 2 factorials times 2 factorial. This is all possible arrangement, but I don't want 2 E's together. So I will figure out all the arrangement in which 2 E's are together and I will subtract that. So when 2 E's are together, these 7 alphabets can be considered as 6 alphabets because 2 E's are together. And then as E's are together, the next alphabet, which is E, 2 E's are together, the next alphabet, which is L, as they are 2 L's, we will divide this by 2 factorial. So 7 factorial divided by 4, it's a 7 factorial divided by 4 minus 6 factorial minus wait. So it's a 7 factorial divided by 4 minus 6 factorial divided by 2. Answer is 900. Now, the second way of looking at the problem is that now as 2 T's are at each end, there are 7 alphabets. Now, in those 7 alphabets, we don't want E's to be together. So we can fit these E's in between two different alphabets. That will also give you the answer, but then that will be little time consuming, I will say. This is the best possible way of doing this question. Now, there is one more part of the question, C part. Let us consider C part. 4 letters are selected at random from the 9 letters in the word intellect. Find the percentage of the possible selection which contain at least one E and exactly one T. So I have exactly one T, and I should have at least one E. So it could be like T E kind of selection or T E E kind of selection. So when I have one T and one E, exactly one T and one E is selected, find the percentage of possible selections which contain at least one E and exactly one T. So here the first case is that I have exactly one E and exactly one T. So first, if I already selected these two alphabets, so I have to select only two alphabets. Now two alphabets out of 9, I will subtract 4 from it first, because all two T's and two E's I will remove. Therefore, I have 5 alphabets remaining. Now, 2 alphabet T and E is already selected. So, out of 5 alphabet, now I have to select only 2 alphabets. So, it is 5C2. So, 5C2 way is what? 5 times 4 divided by 2 times 1 equal to 5 times 2 is 10. When I select 1T and 2E, then in that case from 5 I have to select only one, and that can be done in one way only. Now I have to find out the percentage of possible selection which contain at least one E and exactly one T. So then in that case my percentage is, your probability of doing that is what? 10 plus 5 divided by, now you are selecting 4 alphabets. What are the different ways of selecting 4 alphabets from 9 alphabets? Okay, here I think we are missing something. Instead of dealing it like this, okay, better approach is, I will come to this on later on. From 2T, 1T can be selected in 2C one way, 1E can be selected in 2C one way, and remaining 2 alphabets can be selected in 5C2 way. So it is 2 times 5C2 is 10. So this is 40. Then here out of 2, 1T is selected in one way. Out of 2E, 2 can be selected in 2C2 way. And then from remaining 5, I have to select 1. So that is in 5C1 way. So it's a 2 times 5. It is 2 times 1 times 5 is equals to 10. So therefore, my required possibility will be 40 plus 10 divided by, now out of 9, I need to select 4. That can be done in 9C4 ways. So here it is 50 divided by 9C4 is 126. So 50 divided by 126 is 39, 0.3968, which is 39.7 percentage.